Welcome to my algebra class. We're on chapter 7, section 9. We're going to be working with negative exponents. And if you remember from last year, a negative exponent turns into a fraction where 1 is your numerator and the denominator is the power, but positive. So 10 to the negative 3 is 1 over 10 to the positive 3. And then you work it out, it's 1 over 1,000. 16 to the negative 1 power is 1 over 16 to the first, or 1/16. 5 to the negative 4 would be 1 over 5 to the fourth power, which is 1 over 625. See if I still have my calculator handy. So 5 to the fourth power is 625. I have a good memory. Remember, the 0 power always equals 1. And remember your rules for powers. You're going to need them. If you have a power times another power, two powers multiplied together with the same base, like x to the third times x to the fourth, we add the exponents, so that's a total of 7 x's, x to the 7th. If we're dividing powers that have the same base, like x to the 10th divided by x to the 14th, we subtract the exponents. Let's make that 20. We could cancel out 14, leaving 20 minus 14 gives us 6. X to the 6. Take a power of a power. We have x to the 10th taken to the second. That's x, multiply the exponents, that's x to the 20th. If I have a power of a product like 2x to the third power, the 2 is taken to the third power and the x is taken to the third power, so that's 8x cubed. And the last one, if I have a fraction taken to a power, such as 2 over x to the third power, that's 2 to the third power over x to the third power, which is 8 over x cubed. So we're going to be using all these facts as we do the assignment. So you need your book. Open to page 333. We're doing written 1 to 32 and 36 through 58. Head your paper, skip a line, there's the title. So we're on 333, problem number 2. We're to simplify. So write the original problem down as 4 to the negative 1 power. To make it a positive power, we put 1 over 4 to the first power, which is equal to 1/4. Problem number 4, we have 2 to the negative 2 power. Make it a positive power first, so it'd be 1 over 2 to the second, and then work it out. 2 to the second power is 4, so 1/4. Number 6, we have 8 to the negative 2 power. Make it a positive power, it's 1 over 8 to the second power, which is 1. 8 to the second is 64. 1/64. Use 2 lines for your fractions. Skip a line, number 8. We have 2 to the negative 3 power. So it's 1, positive power is 1 over 2 to the third. And 2 to the third is 8, so it's 1/8 is our answer. Number 10, we have 3 to the negative 4th power, which is equal to positive power 1 over 3 to the 4th. And 3 to the 4th is 81. You can use your calculator to verify that. So it's 1 over 81. Problem number 12, we have 6 to the negative 1 power. Positive power would be 1 over 6 to the first, which is 1/6. Problem 14, we have 3 to the 7th times 3 to the negative 9. The bases are the same, they're both 3, so I'm going to add my exponents. 7 plus negative 9 is negative 2. And that's a negative power, so I make it a positive power by putting 1 over 3 to the 2nd. And 3 to the 2nd is 1/9. Number 16, I have 4 to the negative 1 taken to the negative 3 power. So this is a power of a power. You multiply your exponents, so that'd be 4 to the 3rd power. Negative 1 times negative 3 is positive 3. And 4 to the 3rd power is, use your calculator if you wish, it's 64. 18, I have 6 to the negative 2 power over 6 to the negative 3 power. I'm going to show you a little trick. Since negative powers you actually flip, like 3 to the negative 2 you flip it, I can do that here. So 6 to the negative 2 is going to go down on the bottom, 6 to the 2nd, and 6 to the negative 3 is going to come up to the top. So anytime you have a negative power, it just changes its position in the fraction. So now I can subtract my exponents. There, I can take out 2 6's here, and 3 minus 2 just gives me 6 to the 1st, which is 6. So I'm going to be doing that from now on. Number 20, we have 3 to the negative 5 power times 3 to the 3rd power over 3 to the negative 4 power. I'm going to get rid of all the negative powers by flipping their positions. So 3 to the 3rd stays right where it's at because it's positive. 3 to the negative 4 is going to move up. It'll be 3 to the 4th since I moved it up. And 3 to the negative 5 power is going to come down. So multiplying on top, these bases are the same, so I get 3 to the 7th power, add your exponents, over 3 to the 5th. So I can subtract out 5 3's from here and here, so that leaves me 3 to the 2nd, which is 9. Study that carefully. We're going to use the moving of the negative powers on most of these. 22, I have 8 to the 4th over 8 to the negative 4th taken to the 0 power. Now I don't have to do anything here if I remember the 0 power of anything is always 1. Number 24, I have 3 to the 0 power times 2 over 2 to the negative 2 power taken to the negative 3 power. So let's work inside here. 3 to the 0 power is 1. So I have 1 times 2, which is just 2. 2 to the negative 2 power is going to move up and be 2 to the 2nd. And I'm going to take that to the negative 3. So I have, adding my exponents, 2 to the 3rd taken to the negative 3, which is 2, multiply your exponents, to the negative 9th. And that flips, and becomes 1 over 2 to the 9th. And then using my calculator, I can slide this over here. Two to the 9th power is 512. So that's equal to 1 over 512. Don't go across the fold. If that was too much going across, just go down. Okay, let's try 26. 26, we have 5 over 4 to the negative 2. Now I could take each of these to the negative 2 power. I'm going to show you this, and then I want you to do it the short way. That would be 5 to the negative 2 and 4 to the negative 2, and that would cause them to flip 4 to the 2nd over 5 to the 2nd. So what actually happened is the fraction turned upside down. So instead of doing all that, I'm going to remember that, that if I have a negative power of a fraction, it'll flip and become positive. So 4 squared is 16 and 5 squared is 25. So we've learned 2 new things. Move negative powers up and down depending on where they're at. And if you have a fraction that's to a negative power, just flip the fraction around, right? It's reciprocal. 28, we have 7/6 to the negative 1. Okay, I have a negative power of a fraction, so it's going to flip the fraction to its reciprocal and become positive. Remember, there's always 2 changes. Once you flip something or move it, the exponent becomes positive. And problem number 30. Has 2 parts. A, 4 times 5 to the negative 2 power. So that's going to be 20 to the negative 2 power, which becomes 1 over 20 to the second power, which is 1. 20 squared is 1 over 400. Part B is to drop the parentheses and do 4 times 5 to the negative 2 power. So the power negative 2 belongs only to the 5. So we can move things. It'd be 4 over 5 squared. 5 to the negative 2 goes down, so that's 4 over 25. And 32, we have 2 plus 3 to the negative 1 power over taken to the negative 2. Now some of you are going to make the mistake and think you can take the negative 2 power of everything inside here, but there is no rule about the sum, a power of a sum. So we actually have to work the inside out. So that's 2 plus 1/3. 3 to the negative 1 is 1 over 3 to the first. And 2 plus 1/3, that's 2 1/3 or 7/3. To the negative 2. Now we can flip the fraction. And that's 3/7 squared, which is 9/49. And B, same problem basically, but we changed the addition sign to a times sign, and that does make a difference. So I could take the negative 2 power of everything in here, but I still prefer to go ahead and just multiply out what's inside. That's 2 times 1/3 to the negative 2. So that's 2/3 to the negative 2. That flips the fraction, makes it 3/2, and I'm going to square it. It's now positive, so that's 9/4. Be sure you show all your work on these problems. There's no way you're going to get to the final answer without showing the flipping and the moving. The last part, 36 to 58. Problem number 36. They want us to simplify, give your answer using positive exponents. So we have 2n to the negative 3. Simplifying powers, we never leave a negative exponent in our answer. So this tells me I move the n to the negative 3 down to the bottom and make it positive, and there's my answer. 38, I have 5m to the negative 2. So that's going to flip and put the 5m, keep it in parentheses, to the second. Make it positive, so that's 1 over 25. Everything inside is taken to the second power, m squared. But notice how I didn't take everything inside to the negative 2 power. I first flipped it. Negative signs are easy to lose. All right, number 40. We have a to the negative 2 and b to the negative 3. So that's going to equal 1 over a squared b cubed. Moving these down to the bottom, flipping them out. And that's my answer, 1 over a squared b cubed. 42, I have x to the negative 2 taken to the third. This time I'm going to multiply the exponents, so I get x to the negative 6, which is 1 over x to the 6. You could have put 1 over x squared and then cubed it, but for me this was easier. 44, you have a to the 5th times a to the negative 2. Bases are the same, so you add the exponents, you get a to the 3rd. And that's our answer. 5 plus negative 2 is 3. 46, you have 4n to the negative 1 squared. So we're going to take everything inside and square it. 4 squared is going to be 16, and n to the negative 1 squared is n to the negative 2. So that's 16 over n squared. Remember, the negative power will move it down. Just flip it. 48, we have 3x to the negative 2 times 3, in parentheses, 3x squared to the negative 1. So this would be, there's a couple ways we can do this. I think I'm just going to flip this, so this would be 3x to the negative 2 over 3x squared. I'm just going to move this down right now. And this is going to come down, so that's going to be 3 on top. On the bottom I have 3x squared times another x squared, because this is coming down. The 3's cancel out, and it's going to be 1 over x to the 4th. Again, you could have moved this down right away, multiplied this out. There's a couple ways to do it. 50, we have b to the 5th times b to the negative 7th taken to the 3rd. I want to do what's inside first and add my exponents, so that's going to be b to the negative 2. And I want to finish and take the power of the power and get b to the negative 6, and now I'm going to flip it. So 1 over b to the 6. And 52, I have u to the negative 4 over u to the 10th. U to the negative 4 is going to move down, and there's going to be a 1 on top. So that's going to be 1 over u to the 14th. (54), I have d to the negative 3 over d to the negative 5. They're going to turn around. This is going to come down, this is going to go up. So they just change positions and become positive. That means I can cancel out 3d's here and 3d's here. 5 minus 3, I have left d to the 2nd. 56, I have b to the negative 3 over b to the negative 6 taken to the 4th. If you want, you can flip them right now. B to the 6 over b to the 3rd. Taken to the 4th, the power of a power, you multiply the exponent, so it's b to the 24th over b to the 12th, and then you could subtract out 12 b's and get b to the 12th. You could have also subtracted here and take what was left to the 4th, so a couple ways of doing it. And 58, y to the 5th over y to the negative 2 taken to the negative 3. I'm going to work inside first. So the y to the negative 2 is going to move up and become y squared. So that's going to be y to the 7th taken to the negative 3, which becomes 1 over y to the 7th to the 3rd power, which is 1 over y to the 21st. Again, there's a couple ways you could have done these, but the answer is 1 over y to the 21st power. That concludes the evens. Be sure you check the answer key in the back as you do the odds.